Of course, we have to put my favorite student. It's been a while since we've seen poor Anne. But she's still getting 100%. Says, show your work. Be sure to report the correct number of sig figs. Am I fussy on sig figs? That's left over from a few years ago when I used to be fussy on sig figs, and include proper units. Am I fussy on units? Oh, heck yeah. So check your units. Number 1 is multiple choice. It wants the coefficient of friction. When it's asking for the coefficient of friction, you know what it's really asking for? It's saying, hey, what's mu? I don't know, what's mu with you? It's not looking for the force of friction. That's a different thing. You need the coefficient of friction to calculate the force of friction. How am I going to do this? Well, I would start out mentally or actually underlining that phrase. That's key. Do you have the quiz? Do you have a copy of it? Pardon me? Like you were here last class, right?
Yeah, I did it.
Okay. What does that constant speed tell me? What's my acceleration?
0.
Which means, according to Newton's first law, all of my forces are balanced, and that's going to be hugely advantageous. This is going to be a job for a free body diagram. How do I know? They didn't say anything like net force, which allowed me to go straight to F equals ma, Christy. Instead, I need to realize that I can go winner minus loser. Here we go. We have gravity down, normal force up. I'll call this F applied, 12. Friction. Mateo, what phrase did I underline? Which means my acceleration is
0.
Which means when I go winner minus loser, it's actually a tie, because my acceleration is 0. If you're looking for a slight shortcut, Tim, I can actually say the applied force equals friction. It's going to be winner minus loser equals ma. What's a? 0. So it's going to be winner minus loser equals 0. I'll plus the loser over and I'll get that. You okay with that, Emma? Because it's a tie. Forces must be. I'm looking for the letter B. Balance. Okay. Friction is what times what? By the way, good habit to get into. I would not now put an equal sign here. I'm about to write a brand new equation. So to show that, Sierra, I do a little arrow. That's my way of saying I'm going to rewrite this first equation, but I'm not saying that I'm continuing the same line of thought. So F applied. Hey, Tristan, friction equals what times what? Good. And this question is asking me to find the coefficient of friction, mu. How would I get the mu by itself? What's the normal force doing to the mu? Multiplying. So I'm going to divide. I get mu equals F applied divided by the normal force. There's how I can calculate it. I don't know F applied. Oh, wait a minute. Emma, how big is F applied? Yep. I don't know the normal force. Oh, but look. I know another force that has to be the same size as the normal force because I'm not sinking into the ground like quicksand and I'm not flying into the air like Superman. That's the power of Newton's first. So I can put mg there. Now I'm going to go to my calculator. It's going to be 12 divided by bracket 5 times 9.8. 0.24? A. 1 mark. No, 2 marks. Why 2 marks? I don't know, because it was about 2 marks worth of work. If I had given this to you as a non-multiple choice question, this would have been a 2-marker, so 2 marks. A freely falling object accelerating downwards, okay, that's important, experiences a force due to air resistance of 1.4 newtons. What's the object's acceleration? Chloe, you know what this is a job for? I think so. So I'm going to represent the mass with a dot. Chloe, what are the forces acting on this? Get the obvious one. What else? Air resistance. Which way? Because we're you know what? I need to rephrase this because you could be going up and still accelerating downwards. I need to, just making a mental note right now, I need to say is moving downwards and accelerating downwards, because on the way up, if you're slowing down, doesn't that mean you're accelerating downwards? So if you have air resistance pointing down, I will have to accept that from you because, Maggie, this is an incorrectly worded question. Bad, Mr. Dewick. Bad, Mr. Dewick. Ow. So up, bigger, smaller, or the same size as mg? How do you know that it's smaller?
That's how I drew it on here.
Because which way are we accelerating?
That way.
So which way is the winning direction?
Down.
So which way is the smaller force? Up. And the winning... Okay. I couldn't go much higher. I was running out of room there. And now I have my equation. Gravity minus air resistance equals ma. Winner minus loser equals ma. I would probably give you 1 mark if I saw that, because that's most of the effort. How would I get the a by itself, Chloe?
Divided by m.
So it's going to be mg minus f air all over m. I would give you a half mark for that. And then a half mark for the answer. It's going to be m 0.62, g 9.8, minus 1.4 all over 0.62. And I get... That's a terrible 6. That's better. Bracket 0.62 times 9.8, take away 1.4, close off the bracket, divided by 0.62. Do you get 7.54? Oh, and what's the built-in error check? If there was no air resistance, what's the fastest we can be accelerating in free fall? So I know if I get an answer bigger than 9.8, I've clearly made a calculator error. It's nice to have that in the back pocket just in case. I'll go 7.5 meters per second squared. 2 out of 2 if you got that, even if you didn't show all steps, but I wouldn't take shortcuts on a quiz. Christian, what word is underlined in number 3? That means I can go straight to just saying F equals ma. And they want the net force. Well, I have the mass. Oh, I need the acceleration. So even though this question is saying find F net, you know what I'm going to spend most of my time finding? What else do I know? Is? What else do I know? Is? What else do I know? Is? So, I guess another equation for force, and I would never do it this way, I would never write it down, but I guess you could make an argument that another equation for force is mvf squared minus vi squared all over 2. Do you see why it's much nicer to be able to rewrite the equations however I want? Because I can memorize that one too, Mr. Duick. No, don't. It's, I guess, there, but who cares? I don't need to memorize it. I'm going to crunch it right now. It's going to be vf squared minus vi squared all over 2 times d. It's going to be 15 squared minus 0 squared all over 2 times 85, and that number is going to end up right over there. Bracket 15 squared. Do I need to type minus 0 squared? Will that change anything? And then divided by 2 times 85. I get 1.3235. I'm going to write 1.32, but since this isn't my final answer, I'm going to write 1.32. But what button am I going to hit on my calculator? Yeah, why not? More accurate and less typing, double win, right? So I'm going to go 1200 times, answer button. Do you get 1588.23? I'll go 1590. I'll go to 3 sig figs. 1600, I would absolutely accept that. If you said 1580, I would take a half mark off and I would say learn to round off. 1590. If you said 1588, I'm fine with that too. F equals 1590 units, because it's a force. Cole, has your physics teacher told you it's worth memorizing units?
Yes.
Does your physics teacher hate memorizing stuff?
Mm-hmm.
So when he tells you that something is worth memorizing, is it really worth memorizing?
Yeah.
You awake now? Okay, good. I would probably give you a half mark for that. I would give you a half mark for that, half mark for the acceleration, and then a half mark for the answer. Probably something like that. I don't know. Ooh. Dylan, how many marks is number 4 worth? Might mean it's not just even a 2-step question. It might be a 3 or a 4-step question. I don't know. Let's find out. Dylan, what do they want me to find in number 4?
Final speed.
Okay. Well, I know VI. I know D. What else could I find that would help me find V? So I'm going to go A equals, I'll draw a blank because I'm saying I need to fill in the blank. I'm good at drawing a blank. No, I don't mean it that, well, okay, some of you are really good at drawing a blank. Well, I'll put a blank line there. That's how I tell myself the main thing I'm trying to find is a question mark. An intermediate step is I need to fill that blank in order to get the question mark. So how the heck am I going to do that? This is a job for a free body diagram. What are the forces acting on it? We have gravity down. I don't think we're sinking into the ground. Normal force up. We have an applied force. Oh, and there is friction. I'm going to kind of find A on the right-hand side. So, who's winning? F applied. Who's losing? Friction. That's going to be MA. A is going to be F applied minus friction all over M. Except instead of friction, Tristan, friction is what times what? I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. I think on my next line, I'm going to put in mg. So the acceleration is going to be 56 minus mu mg, 12 times 9.8 all over 12. 56 minus 0.24 times 12 times 9.8 all over 12. Did you get an acceleration of 2.31 blah, 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 blah? People nodding? Yep. So I'll write 2.31. But of course, I'm going to use my answer button because now I can walk this over here. I'm going to get VF squared equals VI squared plus 2AD. Although, Dylan, what was VI? So I can modify this equation just to that. Except that's VF squared. How do I get rid of squared? Cool. So my final speed is going to be 2. I'll write 2.31, but I'm going to use my answer button, times 16. No. I said I'm going to use my answer button, Mr. Dewick. Silly. 2 times answer button times 16. Square root of that. Square root of that. Do you get 8.6 even? 8.60? Sorry, 8.61 if you went to 3 sig figs. Is that right? Hannah nodding? No, yes? Yeah? Before we turn the page, or before we move to the next question, what if your final speed was 0? Could you also find V initial? You might recall way before Christmas when we were looking at our distance equations, I did a lesson, I think it was called Applications of Acceleration. In Rihanna, we looked at an RCMP crime scene investigation where the RCMP had picked up the sound of the skid on a cell phone, and then we were able to use that to figure out how fast the driver was going. And I said to you, that's a little unrealistic. This is really what they would do. You would measure the distance of the skid, and you would measure the coefficient of friction on the road. And from that, you could figure out what the acceleration was, you could figure out what the initial velocity had to be, and whether or not someone was speeding. So we actually now have the capability of doing it properly. Now you can turn the page. Oh, Mr. Dewick, who drew that lovely drawing? I did. Skier is moving horizontally over packed snow. The coefficient of friction between the snow and the skis is 0.11. If the skier can exert 110 newtons of force through her ski poles, what's her acceleration? This is a job for a free body diagram. I'm going to do it right there. We have gravity down, normal force up. Here is the poles of 110 newtons. There is some friction. Who's winning? Poles. Who's losing? Friction equals MA. I forgot to give you the part marks for this question, didn't I? I would probably do something like, oh heck, a half mark if I saw that. Half mark for the answer. 1 mark if I saw that. Half mark. Half mark. I give you more marks for being able to find the acceleration because that's really the skill I'm testing. What do they want me to find? The acceleration. How would I get the A by itself? A is going to be F poles minus friction. I don't know why this one's worth 3 marks. I probably should have made this worth 2 marks because now I think I can go 110 minus mu times the normal force all over m. It's going to be 110 minus 0.11 times 47 times 9.8 all over 47. I'm missing a 1. 110, and I'm missing another 1. Minus 0.11 times 47 times 9.8 all over 47. Do you get 1.26? 1.3? Yeah? 1.3 meters per second squared. I don't know. I'd probably give you 1 mark for that, 1 mark for that. How about 1 mark for the answer? Last one. Steady speed. Gravity down. This is a job for a free body diagram. Normal force. I have an applied force, and that's what they're asking me to find. And the key to realize is that friction and the applied force must be the same because we're at a steady speed. Maggie, as a shortcut, I can say F applied equals friction. I can say F applied equals mu times the normal force. I don't know the normal force. Oh, but look, another force the same size as the normal force. Which one? Yeah, so you're telling me that, oh, I can't scroll down anymore. F applied equals mu mg, which is going to be, hey, what's mu? The coefficient of friction. M, 20, G, 9.8. What was that, Cole? Is that right? I'll go 62.7. Units, Maggie? Because it's a force. 3 out of 3 if you got that. Otherwise, I would probably go 1, 2, 3, 4. Okay. Half mark for that. Half mark for that. Half mark for that. Half mark for the numbers. And then 1 whole mark for the answer, just for giggles. Something like that. I don't know. Can you give yourself a lovely score out of really only 15? Okay. We'll pause. Lesson 7, where we left off, Emma. I'm going to finish off lesson 7. We got to the very last question. And then I'm also going to just start a little bit of lesson 8, which is a continuation of lesson 7 anyhow. And we'll kind of see where we get from there. Right now, I'm thinking probably we can get to your forces test either the end of next week or the beginning of the week after. Okay? That's where we're at. So we'll definitely get it in before spring break. What were we looking at? And so for Nick and for Tristan and for May and for Oliver, here's what we said. What if we have more than one mass? We had to make a slight tweak. Instead of going winner minus loser equals MA, we still did a free body diagram. We still labeled our forces. We wrote an equation along the rope, and we said it was going to be winner minus loser equals the mass of all of them times A, because they were stuck to the same rope. Then Brian, once we found the acceleration, we could go look at individual masses to find individual forces. We treat the whole thing as one big uber mass to find the acceleration of everything. Then we go look at individual forces. And I finished off by saying, hey, we can even handle more than one mass, more than two masses. Heck, we can handle 10 if we really want to. So here's a nice one. Mateo, but not Mateo. Mateo, what does A want me to find?
The acceleration.
What does B want me to find?
The tension of both cords.
How many ropes are there? Psst. How many tensions are there?
2.
So we'll have to find 2 tensions. Okay. Any thoughts on how I might want to start? What do you think this is a job for? And you know what? I'm going to actually just label my picture. So I always start from the left and work my way across to the right. So let's start with that 1. What are the forces acting on it, Mateo? Get the obvious one.
MG.
Which way?
Downward.
And is there more than one mass? I'm going to call it M1G to go with, I'll call that mass number 1. What else?
The normal force.
Is it sitting on a surface?
No.
So is there a normal force? No. Because there's a rope, we'll call that. Is there more than one rope? Yes. I'm going to call this tension 1 to go with rope number 1. Those are the forces on mass 1. What are the forces acting on mass 2? Get the obvious one.
Gravity.
I'll call it M2G. Yes? What else?
Normal force.
I'll call it normal force number 2 to go with mass number 2. Now you said normal force. Is it sitting on a surface? That is a normal force. What else? Now it's going to get a little trickier. Let's look at the left-hand side. Is there a rope? And so tension number 1 is that way. And Emma, this is your forces come in pairs, tension 1 and tension 1 on either side of the rope, either end of the rope. Is there friction?
Yes.
Okay, that's how I'll indicate it usually. Which way? Which way is this going to be sliding? How do you know it's sliding to the right? How big is this mass?
1 kilogram.
How big is this mass?
8.
Which one of those would be winning? Okay, so I'm going to expect you, Sierra, to be able to reason your way that larger mass is going to be the one moving. So if it's moving to the right, which way am I going to point friction?
To the left.
And I'm going to call it friction force number 2 to go with mass number. There's one more. What else?
Tension.
Is there more than one rope? I'm going to call this tension 2 because it's rope number 2. You could call them tension A and tension B. I've seen some kids call them tension L for left and tension R for right. I'm a numbers guy, so numbers work for me. That middle mass is pretty complicated. The right-hand mass. What are the forces acting on this guy? Get the obvious one.
Gravity.
I'll call that M3G. What else?
Tension.
Tension what?
2.
Because it's rope number 2. Is there a normal force? Because we're not on a surface. Okay. Whew! Believe it or not, we've done most of the legwork. Now we just need to ask which way is this accelerating. You already told us. Which way is that upper mass accelerating to the... So who's winning? What's causing this whole chain reaction in the first place? Gravity pulling on the 8 kilogram mass. You okay with that? So anything that ends up pointing that way down on the right when it gets to that side is going to be a winner plus. Anything that ends up pointing up when it gets to that side is going to be a loser. Minus, you're going to wake, that was a long blink. Who's winning?
M3G.
Good. Here's my equation. M3G. And now, for Nick, and for Tristan, and for Oliver, and for May, we're going to write the forces along the rope. I'm not going to write vertical or horizontal. I'm going to walk along the rope, which means because this rope has a couple of bends in it, sometimes I'm going to be moving vertically, sometimes I'm going to be moving horizontally. That's okay. So now, walking along the rope, Mateo, this tension here, winner or loser? Which way did you just decide was the winner? Pointing
Down.
on the right. Which way is this one pointing?
Right. Or up. Going left.
So, up or down here? So, winner or loser?
Loser.
Now, this tension too, I need to use this one here. I need to use my imagination. Follow it, follow it, follow it, follow it, follow it. When it gets to this side right there, is it pointing down winner or up loser?
Down.
So, winner plus. Am I going to include these two? Are they along the rope? So, ooh, friction force number 2. Follow it, follow it, follow it, follow it. When it gets to this side, would it be pointing up loser or down winner? So minus. This tension here, follow it, follow it, follow it, follow it. Winner plus or loser minus?
Loser.
Did you just call me a... Oh. What about this tension here? Follow it, follow it, follow it, follow it, follow it, and down?
Winner.
Now, this M1G, a lot of kids think, oh, it's down, it's a winner. But if you follow it all the way here, when it gets to this side, which way does it end up pointing?
Upwards.
It's a loser minus. Have we got all of the forces along the rope? Did we include any forces that aren't on the rope? Because that's a bad thing. Okay. Equals. You'll notice we have forces from mass 1, mass 2, and mass 3 in my equation. So I have to have all the masses on the right, too. You could also write in brackets M1 plus M2 plus M3, but it's less work to just write M. You know what, Sierra? I agree. Everybody stretch. Good call. Stretch! Oh, I find these so relaxing. Mateo, why are these so relaxing?
We lose tension.
What?
We lose tension.
Nick, Oliver, Tristan, and May, are you ready for my worst joke ever?
Sure.
It's not going to come yet. Hang on. I'll have to save it for a little bit.
Got me all worked up for nothing.
No, I'm preview of coming attractions. It's called a teaser. Tensions vanish. You know what, Mateo? Since there is a part A, let's put a little part A right there, just so we're a little bit organized. What are they asking me to find?
Acceleration.
How do I get the A by itself?
Divide them.
With this long, complicated equation, one of the things I love about these is the end result to get there is usually just meh. How do I get the A by itself? Divide. So if I hear you, you're telling me the M3G drops down, the minus friction force 2 drops down, the minus M1G drops down, divided by M all. And do you mind, Mateo? I'm going to put the A right there. Now let's dive into this to see if we know everything. Do I know M3?
Yes.
Do I know G?
Yes.
Minus, do I know friction? Ah. Tristan, friction is what times what? So on my next line, I'm going to go M3G minus mu times normal force number 2 minus M1G all over M all. Oh, Mateo, I don't know normal force number 2. Oh, but look. Do I know another force the same size as normal force number 2?
M2G.
So this is a lot of writing, yeah? If you want to, I'm okay if you go equals M2G. I'll live with that shortcut. I think that's still organized enough coal that when I look at it, I know what substitution I made. Here we go, Mateo. What's M3? I've scrolled down.
M3.
Yeah.
8 kilograms.
I know G, 9.8 minus, hey, what's mu? I don't know. What's mu with you? What's mu?
0.25.
0.25. M2
Is 9 kilograms.
G, 9.8 minus M1, 9.8 all over M all. How do I find M all?
You add all
Yeah,
the mass.
so it's going to be 1 plus 9 plus 8. Every once in a while I see some kid that thinks M all means multiply, and I see mass 1 times mass 2 times mass 3. Don't do that. I would encourage you, this is worth getting comfortable enough on your calculator to do this in one step, to put the top in one big uber bracket, to put the bottom in one big uber bracket. That's how I'm going to do it. Bracket 8 times 9.8. Take away 0.25 times 9 times 9.8. Minus 1 times 9.8. I probably didn't need to type the 1, but I'll put it there anyways. Divided by 1 plus 9 plus 8. I probably could have done that in my head and said 18, but I'll do it the long way anyways. Do a quick check to make sure I haven't made any typos. You get an acceleration of 2.5861111111111111. All right, 2.58 or 2.59.
2.59.
And it's an acceleration meters per second squared. I might off in the margin somewhere carry a few extra sig figs. 2.58611. 2.58611 dot dot dot. Cool. Brian, what's B you want me to find? There's 2 chords? How about we'll do chord 1 on the left and chord 2 on the right. Did I give you? Yeah, I gave you some room. Brian, which mass would I not want to use? Which of these masses has the most gunk on it, and I'll avoid it like the plague unless I have to? Yeah, I'm not going to use mass 2. So let's use mass 1. Which tension can I find with mass 1? Tension 1. Which way is mass 1 accelerating, up or down? Who's winning? Tension number. Okay. So I'm going to write an equation just for that guy. Ignore the rest. And I'll get tension 1 minus M1G equals M1A. How would I get tension 1 by itself? Is that a phone? Or is that a chair squeaking? Or is that from outside somewhere? Everyone's looking up. I thought I heard Timbits there maybe. Okay. Mass 1 is, was it 1? A2, this is why I jotted down some extra sig figs, because I knew I was going to use it. Plus 1 times 9.8. One times, haha, answer button, plus 1 times 9.8. 12.4? And, okay. Find tension 2. Hannah, I could find tension 2 using this ugly guy. I think I'm going to use Which way is that mass accelerating? Who's winning? Who's losing? Which one? Tension number. Gotta be fussy. So, what's an equation for that one? Tension no. Who's winning? Sorry, who did you say was winning? M3G minus tension 2 equals, and we're just looking at one mass, M3A. Pause the video for 1 second here. Hannah, how would I get the tension 2 by itself?
You add the tension to one side and you subtract.
Yep. What I've called the swappy dance or whatever. That's what a kid nicknamed it last year. So, sure, we'll go boom, boom. So, the M3G is going to drop down like a domino, minus M3A. And do you mind, Hannah? I'm going to put tension 2, tuck it in on the left by itself because that's where we're used to seeing it. What was M3? G is 9.8 minus 8. And I'll use what I jotted down, 2.58611. You know what? That's good to 6 sig figs, so I'll be reasonably accurate. I can't use my answer button anymore because I crunched a new answer already. Eight times 9.8 minus 8 times 2.5861111. I'm pretty sure the ones repeat, so I'll do that. 57.7? Yes, no? People nodding? And that's tension. 57.7? 57.7. I'll put a box around both of these, and I'll have a happy smile on my face. So, last day I said, try number 1. You can skip 2. But if you get number 1 wrong and you want more practice, you can try number 2. Try number 3. Ooh. Number 4, you can add. 5, I said you could do. 6, we could do. Number 7, this is actually from a Physics 12 scholarship exam. I've told you I'm sneaking some Physics 12 in here. I'm putting a star next to that. You should be able to do A, get the acceleration. B says, find the coefficient of friction. I like this question. I'm not saying I like this question, I like this question, I like this question. Cole, what I love about this question is it's so nasty that it's easy that it's tough. If you think about it the right way, 2 lines and you're done. I'm curious to see who can figure out B. It's a job for a good free body diagram. 8 is good. 9 is good. 10 is good. Putting a star next to number 12. This is from an old Physics 12 scholarship exam. You can try that one. So number 12 and the other one that I put a star next to, which I think was 7, that's also my way of saying you're not, Joel, going to have anything anywhere near this tough on a test unless I made it like a crazy bonus or something like that. I was going to continue on, but I think with 20 minutes left, I'll let you, because I've thrown a lot at you, work on this stuff here. So we're going to hit pause.